This is Newton's Principia. It is his published work about linear motion, circular motion, and even gravitation. Since the topic we're going to discuss now is gravitation, well, what better way to start than from the source itself? In fact, I'd like to start off with reading to you what Newton actually wrote about gravitation. About the masses themselves, he said that there is a power of gravity tending to all bodies, proportional to the several quantities of matter which they contain. So what this means is that if you've got two objects, any two objects that have got mass, since they're matter, they must have mass, they will attract one another. In Newton's terms, that force of attraction he is referring to as gravity. Now this, mathematically, we interpret it as the force being proportional to the product of the two masses. You can denote this as being mass 1 and mass 2, or else you can denote it like so, with an uppercase m and a lowercase m, indicating two different masses. So then Newton goes on to say in proposition 8 in book 3 that the weight of either sphere towards the other, he's speaking about spheres here because remember that the context here is gravitation. The weight of either sphere towards the other will be reciprocally as the square of the distance between their centers. Newton here is assuming that the two masses are spherical, but today we do know that that's not necessarily the case. I mean, he said that previously in his previous proposition. And by taking their centers, the distance between rather their centers, let's take that to be r, he's saying that this force is inversely proportional to the square of the distance between them. And if we combine those two relationships, we do get something like this. And if we've got to equate such a relationship, we need to include a constant. In this case, instead of adding any constant k, we are going to rename that constant g. We're using such a letter just because we are speaking about the topic of gravitation. So we just add that constant there, and there you end up with the universal law of gravitation. Now, why is it called universal? What does it mean that this is universal, that the law of gravitation is universal? It means that it applies anywhere within the known universe. So if you're asked about this, what is the meaning of it being universal? That means it is applicable anywhere with any masses within the known universe.